All right, welcome to Quarantined Math, Day 2 with statistics and our special guest star, Majin the Ferret. What we're going to work on today is a extension of what we did yesterday. We're going to keep working on exponential equations, and we're actually going to dive into the packet because the first couple pages are actually strictly dealing with those exponential equations. I know we had talked about going the logarithmic route, but we'll just do one thing at a time. So since we have a couple things in the packet that are all about what we did yesterday, we're going to do those as a couple of those as a group today, and then we will move on to logarithms after we get through those. So get out your packets, go to page 1, don't jump. Go to page 1, and then we'll do a couple examples together. All right, we are going to work on the first couple pages of this packet today in statistics. And the first, I believe, 3 problems on this packet, at least, are just merely data entry and finding equations, just getting some practice with actually inputting the data and getting an exponential regression. So we're going to do number 1 together, and then I'm going to leave the other 2 to you guys. So if you want to put in a data set on the calculator, just to make sure we're all familiar, you hit the Stat button right here, and then you hit Edit. That's the very first option. Now what's probably going to happen is you probably have data already in your calculator. If you do, you're going to hit Clear while highlighting the L1 or L2, and then that will wipe it out. We'll go ahead and put the data in. So number 1 says, a cup of soup is left in on a countertop to cool. The table below gives the temperature in degrees Fahrenheit of the soup recorded over a 10-minute period. Write an exponential regression equation for the data, rounding all values to the nearest thousandth. So here's the deal. I know this says nearest thousandth. We've had discussions in class about what to do when we have different sizes of numbers. I'll be honest with you. I mean, I didn't write this. I found this on our last day there because we had kind of a quick turnaround to realizing we're getting out and we got to have something. So if you round it to the nearest thousandth, that's okay. If you round it in the way that we had talked about in class, also okay. There's no wrong way to do it. So I'm going to go ahead and fill in this data. Usually, whenever you get a data set, the line on the left is going to be your X list or your L1. The line on the right is going to be your L2. So we have our time in, and now we'll put the temperature in. So 180.2, 165.8, 146.3, 135.4, 127.7, and 110.5. All right, so we have all our data in. If we want to do a exponential regression, then what we're going to do is we're going to hit Stat, and we're going to go over to Calc. Now, really on this screen, there's 3 things that we want to know about at this point in time. The first one is a linear regression. That's option 4. Not what we are doing today, but if you ever have a question that asks for a linear regression, that's where we're going to find it at. A logarithmic regression is option 9, LN reg. That stands for the natural logarithm regression. And then finally, option 0 is the exponential regression. So that's what we're going to do today. You'll want to make sure your L1 and L2 are your X list and Y list. If they are not, you can hit second and then the number of lists that you want, and we'll calculate. So we see all this here. So you'll see the standard form for the equation written right up here, y equals a times b to the x power, and we can just fill that in. Y equals 180.37. I know it says round to the nearest thousandth, but according to our class, it's a 3-digit number, so it's okay. Times b, which is 0.9538, but this one, since it is a 0 or a 1 is the first digit, we do want to go ahead and round to the thousandth, and that is going to end with a 4, and then that'll be to the x power. And that's all it actually wants us to do here. It just wants us to write that exponential equation. We'll do the exact same thing in some of these other problems. I want you guys to try out 2 and 3. Do keep in mind on a question like 2, when we're talking about these years, it says specifically here using X as 1 to represent the year 1986. So you're not going to type in 1986 in your calculator. You're going to type in 1 2, 3, so on and so forth. You're going to see that sometimes, specifically with this problem, but occasionally in future problems as well. So taking a look at number 3 here, I know I had mentioned you guys can do this one, but I just saw that it actually asked something at the end of the problem that I really like and I want us to do. So we're going to do this one as a group. So it says a population of single-celled organisms was grown in a petri dish over a period of 16 hours. The number of organisms at a given time is recorded on the table below. Determine the exponential regression equation model for the data, and using this equation, predict the number of single-celled organisms to the nearest whole number at the end of the 18th hour. So let me go ahead and clear my lists on the calculator, and we're going to go ahead and put this data in. So we have 0, 2, 4, 6, 8, 10, 12, 16. And then we have 25, 36, 52, 68, 85, 104, 142, and 260. All right. So we'll define the exponential regression. Again, we're going to hit Stat, go over to Calc, and then go to the 0 option, which, fun fact, if you just hit 0, it'll do it for you. And that's going to tell us our model is y equals A, 27.2, times B, 1.151 to the x power. Now this wants us to find out how many single-celled organisms will there be at the end of the 18th hour. So let's take a look first. What is x, what is y? Well, our x list, or the left-hand column, is x, the time in hours. Y is the number of organisms. So if it's giving us a time, then that means we need to replace the variable that represents time. So we're going to replace x with 18. So to solve this problem, we're going to do y equals 27.2 times 1.151 to the 18th power, which luckily we can just type into the calculator here. So 27.2 times 1.151 to the 18th power, and we get 341.9. But it does say to round to the nearest whole number. Many problems like this, where you're talking about number of organisms, or if you're talking about number of days, or the year, that kind of thing, you'll naturally want to round that to the nearest whole number because the context kind of asks you to do that. You know, we can't have a partial organism, right? So we're going to go to the nearest whole organism, that kind of thing. So we end up with 342 is our number of organisms on number 3. We'll take a look at one other problem. I think we have time in the video here to do one more. So let's see. What is one that is going to ask us to replace y? None of these actually do. So here's what I'm actually going to do for us today. We'll save the replacement of y problems until Monday, because I don't really want to overload us. I mean, you all are doing good just by watching the videos here, so doing a handful of these problems on your own, I am appreciative of, naturally. So what I would like you guys to try to do is solve number 2. That one is really just data input and finding the equation. And then do 4, 5, and 6, which are all kind of very similar to question number 3 that we did as a group, because really in those I think we're just replacing x. Glancing over the questions, I believe that's everything that's looking for. But try those out. If you have any questions on them, let me know. We will talk about it tomorrow, or I guess Monday, actually. And then Monday, we will work our way a little bit farther through this packet, and maybe we'll get to logarithmic equations. I'm not entirely sure yet. But thanks for watching, guys, and I will see you all Monday.